for the support vector algorithm, which involves distance, we need to scale our data before. And other for gradient algorithm like linear regression, logistic regression, neural networks, and also principal components analysis. So for this algorithm, we need to scale, because if we don't scale, so the optimization computation will become distorted, and when we will train our model, it will converge more slowly. So by now we can't really see the impact of not scaling, but in the next modules we will see what really is the problem if we don't scale. So when scaling is not always needed, so the scaling is not needed when our algorithm don't need to compute distances or gradients. So some of them are the tree-based models, like decision trees, random forest, XGBoost, which are algorithm based on decision and not on distance computation. So for these types of algorithm, we don't need to scale our data first.
Can you please say about the fourth one, the threshold-based models? Like, what is it?
Uh, Threshold-based.
Yeah, like, what's the context? I don't get like binary classifiers and using complex. I don't understand the fourth one.
So the threshold-based models. So uh, mm, yes, I'm not gonna lie. This algorithm, I don't know if we will see it this year.
Yeah, because when I looked at it, I didn't get anything. I don't understand like
Yes,
what's
I
the.
will. Yes, I will see it in details to answer to you. But I think yes, this year we
Yeah,
won't
so the
see it.
first, yeah, first ones maybe like the decision trees, and the second one, I guess.
Yes, for the three decision, which are more used for um, for data engineering. So we will see them at the end of our program for
Mhm.
the decision trees and random forest, which is
Okay.
the thresholds one. Yes, if I don't mistake, yes, I think we won't see it in the program.
Okay.
So about the scaling techniques, so we will see three techniques. So first of all, we have the min-max scaling, which is based on the minimum value that we already have and the maximum value that we have. And the goal of this scaling technique is to finally have at the end um, all our values between 0 and 1. So for these techniques, the advantage is that okay, we don't have to assume any type of distribution. So we can use it without knowing if we are in normal distribution, for instance. It's good for neural networks, and it's good when we need a bounded range. About the weaknesses of the scaling technique is that it's sensitive to outliers. So if we have a single extreme value, it can compresses the entire feature range, because what we need to take is is like our lowest value will become the new 0, and our highest value will become the new 1, and then proportionally all the other values will match a value between 0 and 1. So after that, so even now, yes, we can see what it looks like in Python. So here is the new library that we will use for that. So it's scikit-learn. Scikit-learn, we have some functions which allows us to automatically do the min-max scaling technique. So if we take the example of the Titanic like that, so if we have our Titanic about the age, for instance, if we just take a look at some ages, we can have people who have like 22 years old, other who have 35 years old. And with the min-max technique, here are the new ages. So as we can see, so it's ages between 0 and 1. And we can, if we do the same for other features like the fair, we will have the same. So like the fair, we had maybe some values like 7 or 53, but by now we only have values between 0 and 1. Then we have the standardization. So the standardization is another scaling technique, another normalization technique, which use the z-score. So the z-score, here is the formula. So z it equal x, so our actual value, minus the mean of our population over the standard deviation. So some properties to know is that now, so after this treatment, the mean is 0, the standard deviation is 1, and the standardization technique works well for normally distributed data. And so it's used for linear and logistic regression. But the weakness here is that it's still sensitive to outliers, because as in our formula we have the standard deviation, the outliers will impact this standardization, because as you know, the standard deviation stands for the spreadness of our values. So here again in Python, we will use scikit-learn, which allows us to use the standardization scaling technique. And if we look at that, so in general, with the z-score, our new values will be between -1 and 1. With the mean, because the mean is 0, so we will have some values at the left and some values at the right of the mean. And about these techniques that we saw, so the min-max scaling and the z-score standardization, the problem is that we are impacted with the outliers. So this is why sometimes we can use a third technique, which is called robust scaling. So as its name is indicating, this the benefit of these techniques is that it's resistant to outliers, and it's the best choice when data contains extreme values. So in the formula, as we can see, it involves the median and the interquartile range. So two indicators which are not impacted by the outliers. And once again, so in Python with scikit-learn, we have a robust scaler which allows us to use the robust scaling technique. And if we use it for instance for the age, we can see that for the age, the mean is now close to 0. The standard deviation is almost 1, and all the values are between -3 and 3. So what we can see also is you can see the representation of each scaling scaled data. So for the first one, as we saw, for the min-max technique, by now the age is between the new age is between 0 and 1. With the z-score, we are in between -2 and here 3. And with robust scaling, it's almost the same. So with the scaling techniques, by now we don't have so much. We have a standard scale for our feature. So if we have different features, we will be able to have almost the same scale for each feature. So if I make a little sum up, so in min-max we have a range which is between 0 and 1. In z-score and robust scaling, it's unbounded, but it's pretty little, pretty small. The spreadness is not so high. And then about the central measure in the min-max, so we have the minimum value for z-score, the mean, and for robust, median. We also have a different spread measure each time. The sensitivity to outliers is increasing with the robust scaling. And for each data scaling technique, we need to check if we are in the good use case to use it or not. So so yes, so what you need to remember after that, so is that if we choose the wrong technique of scaling, we can distort our model. So choosing the right technique will accelerate the learning of our model and will improve its accuracy. So by now, I will give you a little exercise to make in group, and I can share you the notebook in Telegram if we need if you need to see it in details.
Yeah, if you didn't send it before.
So so for this exercise too, we will use the Titanic dataset. So So as last time, to use the dataset Titanic, don't remember that we can use the Titanic dataset through an URL. Then we will have it for sure. Mm. Mm. Okay, so I just put the assignment in the chat, and then I will put on Telegram. And by the way, in Telegram, I activated the direct messages. So for those who want to talk to me, normally you can join me in Telegram.
Yeah, I've seen the message today popped up.
Arthur, can you speak louder?
Yeah, I said I have seen the message popped up today from the Telegram.
Okay, okay, perfect. So you all have the notification. Perfect. Okay. Mm. Okay, so I will create the rooms, and during this time I will share you the notebook in Telegram. difficult? Was it medium? What is your feedback with this little exercise? For instance, so for the group of Armin, Arthur, and Boris, can you share us your solution and also your difficulties?
Is it a little bit difficult? Yeah, I wrote in the on Linux. Yeah, not yet is finished because I have the problem for running. If you wait 1 to 4 minutes, I should update. So do update. Huh? Yeah, I think.
Okay, okay.
Yeah, just problem for running. Yeah, I want to. Yeah, I should waiting for the finish the update.
It's okay. Thank you, Ami.
Okay, okay.
So we
After
will.
that, I will show you. I will show you after that. Is it okay?
Okay, yes. Thank you. So we have the time for a group before yours. So Armin, Arthur, and Maurice.
Arthur will now say everything.
Yeah. Just a 1 minute. Let's go.
Okay. So is there maybe the first group or the third group who is ready?
Yeah. Can you repeat what was that? I was in the second line. I didn't hear what you've said.
Okay, no, I'm waiting if the first or the third group is ready then to present the solution.
What group was ours? I didn't notice what was our number. I was with Armine and
Yes, so the
Can
first
you
group
hear?
was Alexandra,
Yeah.
Gor, and Arut. The second group was Amir Hossein, Azat, and George. The third group, Narod and Sana. And the fourth group, Armin, Arthur, Boris.
Okay. No, чика. So, yeah, I can introduce a written example. Tax just
Okay, thank you, Arthur. But I want your group to introduce, not just you.
No, it's just that we did it by parts. That's why. So, let's screen. Yes, yeah. I will just, yeah. Сейчас. Miliope. Not that. 1 minute. Yes, check. Yeah, okay.
So you will introduce your
Yeah.
solution, but I want you to analyze just one curve.
Okay.
The curve of the age.
Miliope. Can you view it now?
Yes, now, yes.
So,
Yes, if you can put it in full screen, yes.
Yeah. Okay. Yeah, so I looked at your file that you've uploaded. So based on that, okay, so the data set we read it, then we selected our required columns. Remove the age because we're not using it. And here, if I run it, let's run Miliope.
Yes, and just we remove only the not the age, the total row.
Yeah. Sorry. I misspelled. I just guess why it's not. Ah, so already running now. Neatesísnas chcemy sobie. Aha. Cóż. Take sense. Okay. So, this is the three different versions, I guess, how it's scaled, huh? Okay. So what else? Transformation. Standard. This is just the basic methods that was written in this sklearn directory, and this copy. Yeah, just like this one is just storing the copied version of the dataset parts. I guess just this one is for visual purposes. And title. And this is just the titles in order to show this overall image processing namings. So just the simple example, nothing too complicated. The same as that you've uploaded in the file on Telegram. I can zoom out, Hosti.
Thank you very much. I want you, but not only you. I would like to hear your team members too. But yes, I would like to have a little analysis of the min-max age curve. I would like that you analyze it. You explain what is going on.
Okay. That's min-max.
So the first curve that you have.
A minute. Let me just zoom out. This one, right?
I run it now, but it showed me just one curve, the maximum, minimum, fall, anything. Just one. It showed me.
Sure.
One moment, I mean, because you're talking about your solution, right?
Okay.
Okay. So the min-max one, right?
Yes. The min-max curve. So the curve, the first graph that you have.
Okay. So
yes, the first.
Ducks. 1 minute. So this one. Yep. Let's see. Okay, this one. This one we're choosing the only needed columns. Which one?
Just what I want is that you explain the curve.
You mean
yes.
the diagram, huh?
Yes. Yes, not the function with a scikit-learn. Yes, I'm just talking about the the diagram. Yes.
A minute. Min scalar max diff h fitness from the fh. So it's transforming the h column, so the every value becomes a number in here, if we can see. So it's I guess either like 0 or 1. And Yeah, it's there. Count. I just don't get the. Yeah, see you.
In reality, it's not complicated. I just wanted I just wanted you to explain again what I just said before. So what we see is that all the values which are between which were between 20 and 40 years old are now so in a specific interval.
Now I think I get it. So you mean the like how this graph works? So the 0, 1, right? It's the youngest person in the data set. If we can see on the left side, Jushta, right? This part.
I just
Yeah.
wanted you to say that. Okay, so the min-max is define all the values that we had, so between a specific interval, 0 and 1. And as all the ages were between 20 and 40 years old in the Titanic, this is why the curve is really high and thin. Because min-max compress the distribution.
Yeah, just information is too desperate, huh? So many ages are different. And nothing.
They are not dispersed as that in reality. But I will show you. I will show you after. I will show you after that the values are not so dispersed in reality. Because at the origin, all the ages were approximately between 20 years old and 40 years old. So the dispersion at the basics wasn't so high.
So I think many passengers here is like middle age range from here, right?
Yes, but by now we can't really talk about the ages because it's new values. Here we just have the scaled age, so
yeah.
So it's a new value corresponding, yes, to the distribution that we had before. But just the interpretation that I was waiting for was just the explanation of what is this graph. So in just few sentences.
Is the identical to our original age distribution? It's the only the numerical range is changed here. That's it.
Yes, in reality, it doesn't change the original distribution.
Yeah. Only this numerical range changed.
Yes, exactly. It's just a new scale. It's not a distribution change. So in reality, it was the solution that I was waiting for, except for the plots, because I was waiting for the three curves to be in the same graph, but like that, it's okay.
I don't. But if it's three versions in the same graph, how will we like? You mean connected or you mean like
No,
disconnected or how you mean
yeah,
in the same
yes.
graph?
Yes, in reality, they will be in the same graph, but yes, it we won't really be able to connect them because yes, it's not the same. It's not the same distributions.
Even these like numbers are different. Like from yeah, they are different. Yeah.
Yes,
So,
in reality,
no way.
because we use the three different scaling method. In reality, yes, we can't compare them thanks to the graph.
The only understandable one was the first one. These two other ones are strange option.
So in
Okay,
uh,
so yes, Boris. Okay, so we don't have many time, but I just want to someone from another group to explain the second graph. I just want the interpretations of the two last diagram, and it's okay.
Do you want to see my code?
Is it your code working or not?
Yeah, right.
Yes.
Yeah, right. Do you have my share?
Yes. Now yes.
Yes. So wait a minute. Show me this.
Mhm.
And the code is not control. So I wrote the import, and it mean the import the three scaling method. I mean method
Mhm.
from the scaling layer. Yeah. And here the URL from the GitHub, and this is for df for read and receive the URL. Here the age for class, and yeah, here we have the minimum maximum also to
Mhm.
create the minimum, the max, the scalar object. Here also, is it okay for me? It was okay, but I have also problem for
You had
the
the problem at
for
which step?
the yeah for the next. Wait, I will show you. I will show you. It was not not easy, but is it okay? But here, I'm not understanding. PLT, yeah, this part.
Okay, but so
For the
which
draw, how to draw, I little bit I know about that. For example, the
yes, but
yeah,
we won't see this because it's not the it's like the cherry on the cake, you know. It's not
mhm,
the main subject. It's not the subject of the class. It's just about plotting
mhm.
our curves. And I guess you use the matplotlib, right?
Yeah, because I'm not also understanding this. I wrote this. Wait, to here is it okay? I write. I swear. Is it too much easy? But after that, I don't know what should we do. And after that, to the ask layer, it give me this part, and it was the new for me. I don't know what's this. Yeah.
Okay,
No,
but
it's the label. I don't know. It's the alpha 0.3. Everything is new. I don't have any idea for this one.
Okay, we won't see this in detail, but first of all, you define the size of your figure in which you will have all your plots, and then yes, I have to check again beans and alpha, but I guess it's because of these two
Yeah.
parameters that you have some.
Mhm,
You know, your graph is not continuous; it's just
yeah, my
like an
graph.
histogram.
Yeah. It's like this. My graph. Yeah, it's
Yes, I
different.
think beans and alpha are for the bar diagram because
Okay.
I can show you mine.
If you wanna show me, I should stop the share. Is it okay?
Yes, yes, you can stop the sharing.
Okay.
So, so in reality, for the code, you understood the principle, and so when we have our three diagrams, I put it in the same diagram, but in reality, yes, it was not really necessary. But you have the same in reality. I mean, you have the like
Yeah.
three bars,
Yeah. 3 bars. Yes. Exactly.
but so yes, what you need to understand is that to
Yeah. Yeah. I don't have
what,
this example. Yeah.
but what you need to remember is that for the min max age, so first of all, we had some ages. By now, all the ages are corresponds to values between 0 and 1. And then yes, then for the fair z-score, if we had analyzed the fair column, we could see some outliers, and this is why we have the bell curve,
Yeah. This
but
one
you.
is
Mhm.
like totally. It's like I mean this one this diagram. It's look like the totally, but scroll up, please scroll. Show me another one. This one. Yeah, yeah, yeah. This one
Mhm.
it's like for example just age, you know, just age max, just the first of the score. This is just about it's just about each.
What the first? Yes,
Yeah, 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 yeah. The first.
yes. The first is for the age. The second is for the fair, and the last one for the P class.
Because
But
yeah.
in the fair score, what we saw is that when we have normal distribution, normally we have a curve, and then that's all. But here we have the curve, and
Yeah, yeah,
we have it continue. All that are outliers.
yeah.
And finally, with the P class, what we have is three summits, because in
Okay.
reality, P class is not a continuous variable like others. Like class, we have I guess 3 class.
All right.
Yes, for the
Okay.
class, I think we just have yes, first class, second class.
Mm-hmm.
Mm,
Distance, value.
yes, first
Uh-huh.
class, second class,
Second class,
third
third
class.
class.
So this is
Okay.
why all the three variables have distributions totally different. But the goal of this exercise was just to test some scaling techniques. So the min-max, the z-score, which doesn't, which keep outliers, and finally the robust scaling, but here is the robust scaling, but on a non-continuous
Non-continuous.
variable.
Yes. Okay. Thank
Yes.
you.
So, guys, here is the end of this course. So, for the next course, we will see, we will talk about SQL. So, I invite you to begin to explore SQL if you don't know SQL. And
Finally. We got the SQL.
yes, the
Okay.
SQL. We will talk about SQL databases and also SQL injection. So I invite you to explore SQL before, and it will be the last course of this module. So be ready because for the next quiz, so there will be more Python than ever, because by now for those who didn't know Python, by now it's like I don't know, some weeks that now we're talking about that. So guys, I invite you to see SQL, to continue with Python, and see you to Tuesday. So good evening, guys.
Good evening.
Thank you. Good evening.
Okay. Goodbye.
Goodbye. Finally, you want to
Yeah,
prolongate. You want all to
yeah.
prolongate the course.
But SQL, you mean the get data, add data, I mean remove data,